So today we're gonna pick up where we left off, except it's a little bit special. So if you watch the recap, you'll know that when I looked at the results of what we did last week, they were all messed up, and at the time I recorded the recap, I wasn't really sure what was happening. In the meanwhile, I've actually figured it out, and so I'm going to show you what's wrong, and then we will we will keep working on this. So let's go step by step, right? Let's get rid of this. Let's go back a bit, and let's do a recap of what we did last week. So last week, we had worked previously on the E. coli genome, and last week we expanded that. So we downloaded a bunch of other genomes. So all of these, B. subtilis, Listeria, Campylobacter, Staph aureus. So we got these genomes from progenomes. We got the representative genome, and all of those are actually single contig genomes. We check that as well. Let me make the fonts a little bit larger. So we check that as well. And then we took the code that we had written before, and we expanded it. So instead of being specific to E. coli, now it would loop over this input all of these different genomes. So still not a lot of them, but several of them, and it would process them as before. So it would compute the gene sizes as a function of the increasing number of mutations, and it would run checkm2 on all of them. Then when I ran this, because checkm2 takes several hours, I ran this, and somehow when I looked at the results, everything was really messed up. And I see. Let me just adjust here a tiny little thing. I'm gonna adjust the logo in the corner because I can see that it's a little bit good. How do I get this? Okay, I'll figure this out a little bit later. I put in the QT logo in the bottom right there. If you see, oops, how does it point? Yep, it points there. It's a bit weird. So if the QT logo is a little bit cut off, I'll fix that later. All right, so back to this. So we looked at, so everything looked okay. The code ran, and then unfortunately I didn't save that messed up image, but everything was messed up. So then I ran it the second time, and it was still a little bit messed up. And then eventually I just, over the weekend on Friday, I cleaned everything and I left it running, and it looks good now here. So maybe I will show you what it looks like now. So this is the same code we had before for E. coli. And does this still work? Okay, this works. Yeah, this works. And then I need to here. I'm gonna put this here a little bit here. Yep. And now it works okay, right? This is exactly the same as we had before, with this little peak on the right, which I've always interpreted as just pure noise, but maybe, and this is exactly what we had before. Right, so everything is good, everything is saved. So what happened? So why were the results so messed up in the previous version? And so after yesterday playing around with this, I think two things happened. So one is that we have here, this is how we run checkm2. Checkm2, conda run. Now, and this works quite well, right? But let me show you something. This took me a so run, right? Right, I'm gonna run as okay, let's write this command. Let's do, let's even a minute. Okay, so if I run this, prints the numbers, nothing special. If I type Control-C, it will stop. So it's no longer printing the numbers. So if I, yeah, see, it's very smart, this thing. So if, right, so now I wrote a program or wrote a Python script that calls print the numbers. And if I type Control-C, then I interrupt my Python script, which interrupts mine. Okay, maybe you see that this is going. But what if I now do this? And I'm going to run it. Oh, sorry. Yep. Forgot to run. Okay. Oh, apparently, first of all, there's maybe a little bit a lag at the beginning, but this should print the numbers. Okay, first of all, on the run and no. Okay, it's a bit weird. I actually expected to see the numbers, to be honest. See, okay, we're actually learning here. It is printing the numbers, but where are they going? Oh wow, I know. Okay, I'm gonna do some. What if I just do the first 5 numbers? Yep. Okay. Wow. This is very okay. This is interesting. Okay. This is the first interesting thing is that we see that we see that there's a bit of a delay. So if you're not, so what happens is that this delay is because of buffering. So right now, somehow the printer numbers no longer thinks it's printing to the screen. It thinks it's so it does this buffer thing. So that's interesting. Let's see, and let's see if I do Python run printer numbers, I should see the same thing. So it should take a little bit of a lag, extra lag maybe because it has to set up, and then okay, now let's see what happens if I do this. And now while it's running, I typed Control-C, right? So I interrupted it, and we're learning. Interrupted it, and will it still print the numbers? I guess not. Okay, this. Okay, all right. So there goes my theory. So yesterday what I was seeing is I could, if I ran things with a couple of these levels of indirection, where I run a Python command that then runs conda run, I would interrupt the first command, and the second one would still be running in the background. and for some reason this would yeah, and this would just keep going. Maybe I'm actually curious about this. I'm actually going to check. Could this just, so this seems to work, right? If I run numbers, the buffering is a little bit annoying, but it kills it, right? Now it's running, Control C, now it's dead. Is it a checkm2 failure? Okay, so I'm not running. So here, by the way, so this is PS, shows you the running process. Then this is just to show you everything. And then I'm just checking that, grabbing for checkm or checkm2. Right. So I had this, yep. So okay, so I have this, let's say I have this directory here with all of the checkm2 inputs, and now if I, okay, it's checkm2, all right, it's running checkm2. And now if I type Control C, so this is what I was seeing yesterday, was that at some point I could type Control C and it would keep checkm2 would keep going. And I think I needed at least, I think, maybe one more level of indirection. And so okay, so checkm2 is running. All right. It's tricky to trigger this. All right, checkm2 is running. It's running a bunch of prodigal things. I type Control C, and it's dead. Okay. Okay. Anyway, all right. It's a bit trickier. I guess it's a bit trickier to trigger this than I expected it, because yesterday so what I managed to do yesterday is to get into a situation where I could kill the top level program with Control C, and somehow checkm2 kept running. What this means is that, so I have one instance of checkm2 running. I'd kill it, and now that would be gone. Or that would keep running in the background, and then if I started a second instance, then they basically would end up somehow fighting, because they would end up writing to the same directories mistakenly, and that would lead to some very confused results. And I think this is what we were seeing. So, oh, there it is. See, yeah, so I killed the top level program, but checkm2 keeps going. Checkm2 keeps going. So there's an instance of checkm2 running, even though I've killed the top level program. And now I can remove the outputs directory and then rerun it. And now I will have two instances of checkm2 both writing to the same directory, and since they will start fighting for their intermediate files, and the results will look all messed up. So it took me a while to figure this out. I've actually was also looking a little bit into the checkm2 code, and as part of that, and I can show you a little bit. As part of that, I also found I made checkm2 a little bit more robust. I'm not sure if it's going to help, but I've contributed this patch to the checkm2 open a pull request. So see, I think this. So you can see, for example, that checkm2 would use the subprocess.call command or .call function to call diamond and to check for diamond here, and here to call. And I'm open a pull request to transform from call to check call. I mean, quite frankly, this type of thing is, I would call this a bug in the Python API, because so you have, this is a very, maybe to put it in the most insulting way for Python as possible. I mean, this feels very much like C++, where you have the simpler API, just a function call is the unsafe version, and if you want to do things safely, you have to type more and remember that it's called check_call. Whereas the natural way of doing things is more unsafe with less error checking, which quite frankly is something that you expect from C++, because C++ is, that's what it is. But you don't, I actually am a little bit, I think that Python, the default should have been the safe version. Anyway, so this was a big detour, but, as I said, last week at some point I thought, I'm gonna try to figure this out before showing these results. There's something wrong here. Not sure exactly. Oh, by the way, let me see now checkm2 is running. And for example, and this is still the standard checkm2, not my version. The other thing is, so for example, here I can kill diamond. Yep. And yep, diamond's dead. Okay, so I don't even know what checkm2. And so what is it? So I wanted to show the results. I was hesitating whether to show these weird results where everything was obviously wrong, but you don't, because you saw that the completeness would go up and down. Hesitating what to do with that, and then eventually I decided that if this is supposed to be extremely open science, spending half an hour debugging what's wrong with this program is pretty much what we do on a day-to-day basis. And my curiosity did get the better of me, so I did spend some time off stream trying to understand this a little bit better, looking at the checkm2 code. I did make it a little bit more robust. I'm not sure that that my patch would even fix this issue, to be honest. I think this is a very weird corner case. You have to. So if I run checkm2 on the command line directly, I think I don't get this effect. I think if I run checkm2 like this, I don't get it. It takes a couple levels of indirection. There's something wrong there. There's something a little bit off. Anyway, so what do the results really look like? First of all, let me just clean up here a bit. All right, I'm gonna remove this number printing stuff because apparently I was wrong. Okay. I'm gonna remove these because we can always these, and okay, I'm gonna start cleaning up but first let's do the plotting. So this is the plot script we had. So I showed this before, where this is a fairly sort of more advanced use of jug, and we had this. Yeah, so this is what we'd seen before. Now let's move this a little bit into, or generalize this into for this works. So instead of E. coli K12, see. And actually, since we're in this cleanup mode, let's put all of this in I call it plots. But let's put all the plots in a separate directory. I'm gonna create the directory. Actually, let's not do that. Let's do it this way. And before. Yeah, all right, let's do it this way. Now let's create the plots directory. And here it is. And now let's since we're all in this, let's remove the graphs that are not in the plots directory. Just delete this. Yeah, and now things look much nicer. So there's a, all right, we're gonna add this, let's add this directory. Let's do the ignore. Everything looks much nicer. Okay. So how do things look like now? All right, so we've, so they all kind of look like this, right? So there's the completeness goes down. There's some noise, but the completeness goes down, but the average gene size goes down significantly faster, right? And if we look at when we zoom in on up to a smaller number of mutations, this effect is more pronounced. Right? We have, especially here on the far left, right, this initial drop of gene sizes quite quickly, despite the fact that despite the fact that the completeness is still 100%. Maybe, yeah, right. Okay, so all right, so this is what we have. Mystery solved. Oh, this is also a nice interface. Mystery solved. Let's see what we do next. Okay. So this is so what did we do? We so we had the answer for why the previous code, the previous results were wrong. Control C. All right, so generalize plotting code to all genomes processed. This is okay. Okay, so this is it. It's nice. We've cleaned up. Everything looks good. So what should? No, well, I'll clean up here a little bit as well. Let's. So this is the checkm2 output for E. coli when we run it, and there you can see. So the results are out of order, which is partly so. So this is 50 mutations, so 100% complete. 600 mutations, 99.3, and you can see it goes down. Because you're going to see that they're out of order because it goes from 49,650 back to 100, and now there's another chunk. I don't exactly know how this happens, but this is what we see. So we see, and you see it happen a couple of times. So here now, and it goes back up. We have here the diamond output. So this is what I wanted to look a little bit, maybe a little bit closer today, trying to understand what's going on here. So here's the diamond output. And you can see, so actually also as part of my investigation into checkm, I also just realized, or now I understand why. So the diamond output, you see, has two files. At the beginning, I wasn't sure why, and now I looked at the checkm2 source code, and it shows that when you have a lot of inputs, it will process them by chunks. And so this is chunk 0, and this is chunk 1, and there's really nothing more to it than this is chunks. There's nothing special about them. The results as a whole are perhaps best understood as the concatenation of the two, right? Right. So we're looking at this. And you can see it uses. I like that it uses this omega symbol for some reason as a separator. I find it cute. And so it has. So here's the original file name, and then here's the protein name or predicted protein name, and then an annotation. And I guess this is a KO. Right. So let's. So what I wanted to now just check a bit what's happening. So let me see. Just going to start a new. So what I want to do is I'm gonna load this. I want to load these two. It's not sep, it's separator. Yeah, someone was commenting the other day that one big disadvantage of using polars instead of pandas is that Copilot will give you panda suggestions and not polars ones. But yeah, so okay. work. Sorry. Okay, this might actually be a, yeah. Okay, this comes back to, yeah, header equals none. That's a pandas. That's a pandas thing. So like, how do you say header equals none in polars? Has header. Yep. How do we? That's correct? No. Yeah, maybe. Maybe. Okay. Yeah, I'll go with that. Yeah. Why not? What? It seems correct. Why should I not believe it? Data. Yeah, this is pandas. Yeah, this. What's the, how do I type an omega? Omega. So no, that's not a mu. Oh. Why? No. Okay, I don't know how to type an omega. So I'm going to do this. Okay, so let's add. So this adds a column called genome that takes the query, splits it. Let's call it Q. And okay, so now we have data genome. Oh, actually, I should have done the same. So here. Okay, now we have a data genome and data KO. Right, very good. And now data group by genome ag. So what I want to do is for each genome have a mapping that goes from genome name to the set of KOs. I'm not sure that this works, to be honest. I'm not even sure that this is. Let's just polars group by. Okay, first of all, it's group by. Okay, is it group by or group by? Alright, grouped underscore by is the preferred spelling, so let's just use that spelling. Group by, and then okay, this works. Why not this? Okay. Okay, this. Okay, so we're making some progress here. Still doing a little bit of pandas. All right, so the yeah, this one. Okay, so this is iterate. Can I just iterate over this? Fold. Oh, okay, that takes a all right, this is this would work, right? Okay, this is awful, but let's just do this. Add polars to the series. Okay, this. yeah, so this. Yep, this is this seems more correct. Yep, this seems about correct. All right, so this seems correct. Let's just do this. So actually, we don't. All right. All right. So this is what I wanted to do. So all right. So now we have for each. Okay. All right. So now. All right, so this should be, actually let me do it this, let me just maybe even rename this a little bit. Okay, so this is what we wanted. Okay, so let's say this is the correct one, right? So now we can do something very simple like this. So we should take the number of specific. Okay. All right. So what's okay? So we can see. It's very good. So we can see that that we have these are the correct ones, and so we as the number of mutations increases, we are not all right. Let's do this. Let's do this a little bit more formally. So, yep, this is about. So what I want to count is, all right. So I have the correct set. So which I'm going to say is the 0 mutations one, and then I have false positives and false negatives. And I'm gonna, okay, this is actually false positives and false. All right, very good. And now, okay, I need to fix this. Sorry, I'm going to do it slow today. All right, so okay, let's do the same. So with the false negative. So these are the all right, these are the number of genes that are missing, or number of KOs, right? Right. We should taboo the word gene, right? In the sense that we should not use the word because right. So this is the number of KOs that's missing, and then let's do this, and then this is the and you can see there's a different scale there. Let's do the same. I'm just gonna get moving the imports up. Up. Okay, right, so this is pretty good. Let's just do this again. All right, so something wrong here with the. We'll fix this in a sec. But this is all right. So this is so green is a false negative. So and let's again just zoom in on the. Right, we start missing genes. False positives. Wait a minute. False positives. I was. Wait, let me. All right, let me double check this because I was thinking about this. All right, let's just do this from scratch, okay? Because now I'm a little bit confused, right? Okay, we do. Let's do tag E. coli. All right, we'll load everything. Okay, we get the inputs and the KOs. We group this by number of mutations. All right, correct or unmutated. I'm gonna call them unmutated KOs. Okay, false positives. So false positives are, okay. Oh, this is not number, this is, oh yeah, okay, that's fine. False positives are, means they're there, but we don't see them. Or the false negatives, the ones that we miss. Alright, this, okay, yeah, so the false positives are varies. And the false negative. All right, so this makes sense. Oh, okay, I see the problem. Okay, so that, yeah, so this was the issue, is that, yeah, I had put the label on the wrong, because it seemed that we were getting thousands of, false positive KOs, which doesn't make much sense, right? So we should get missing KOs because the genes are not being, they're missing. We had seen that the genes were truncated, but we shouldn't see these new KOs popping up. I'm assuming that this is. I'm actually assuming that it's not even a big deal. It's just so in the sense that sometimes KOs are related to each other, so we probably get some similar gene to the real one just because, you know, it was close to the threshold between the two, and so now we see it. Okay, all right, so we are actually quite so what I'm gonna do now is I'm just gonna, so this is the plotting script we had. So, and since we added this is the plotted script we had. So I'm just gonna, at the end, add this. So let's merge these two things. So this is new, but this we need. So let's just put it there somewhere. Let's reorganize this a bit. All right. Okay. Then we had this big loop over all of the different tags, and now okay. Okay. Okay, let's just, okay, so this is fine. Okay, glob was missing. All right, so this is everything we had before. Okay, yep, missing comma. Oh. I need to go get the second coffee, I think. Had one this morning, but it's been a while. Okay, so this was... Okay, oh, here we don't need this, because this is the same as... So this is just, yeah, this is just a little bit of defensive programming there. So just to check that, you know, if we did everything correct at this state, the number of these two things should be the same. And then we do what we did before, except now let's do it this way. Okay, and we're right on time to run this. Okay, so let's look at the very quickly look at what's happening with these. So, all right, actually, okay. There's a bit of a variation in the different versions of Python, so I'm gonna ignore all of those warnings for now. It's not a great thing. Actually, let me just, I was gonna say we can look at it next week, but let's just, it takes map elements, so we call map elements. Yes. Does this work? So if does this make it go away? No. Go away. Yeah. All right. So this went away. All right. So yeah. So the. Okay. All right. This is the second. I made this mistake last week or 2 weeks ago. Which is generate these tag with the literal word tag instead of the. Oh, very interesting. No, not. You can see false positives. It's mostly the false negatives that matter, right? The false negatives is the lower completion as the number of genes goes down. So this is what we're seeing, 5K. Number of missing KOs. So even a smallish number of mutations and we're already missing hundreds of genes. It's actually quite interesting. Okay, so let's just commit and write things down. Stream nodes. Analyze. Genomes. Yep. 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 Check. Okay, space. Yep. Okay, I'm gonna push. And all right, so yeah, so I'm not sure. We have some notes for next week. So we'll probably continue just exploring a little bit. So I think right now we're part of this phase of the project, or it's not that this is a deterministic thing, but it's fairly common to get into these phases where it seems that there's something here. We have proof of concept, I think, in the sense that if I this let me pick E. coli just because, right? Yeah, so this green line, this is what we were seeing on some real data from Anna Kusko. As the, well, we didn't have the x-axis, but we imagined that we had some less polished genomes, and as we moved them to more polished, we saw the completeness increase by quite a lot, even though the number of mutations or the number of base pairs was not changing. So the green line here is what we saw, a couple of dots of it in real data, and now we're seeing it in simulation, which is very reassuring. So this is the proof of concept. We can also see that maybe there's a space here where there's still a blind spot for CheckM to tell us that, okay, this, if we have two genomes, CheckM2 stops being able to distinguish them around here. Even here it's not, but we can still make a bit of progress there. It's also just an interesting question from the point of view of we like to understand what's going on. It's not just or not only about can we filter genomes, yes or no, in which case CheckM2 actually seems to be doing a great job at it, but also can we understand why some genomes are better than others. Right, so we've achieved proof of concept. And now it's a little bit unclear exactly how we move forward, to be honest. And so I think at this stage, I mean, there's a risk that we will get a bit bogged down in these rabbit holes, but a lot of the sort of feel of these projects is trying to figure out which are the rabbit holes down which we should go, and which are the rabbit holes which we should avoid. So we're maybe going through a rabbit hole in this KO exploration, maybe not. It's a little bit unclear. So we'll keep going. We'll keep doing some rabbit holing probably for a couple of weeks. Obviously this would be, if I was working on this full time, this would go faster. This would probably, but here, we will keep exploring, and then maybe in a couple of weeks, maybe by July, although July or August, I'll be able to look a bit, to do sort of a stop, evaluate, see, how do we convert these intuitions that we're now gaining. So I think one way of thinking about it is, okay, now we're trying to gain intuitions into what's happening, trying to gain hypotheses, generate, and then at some point this will have to switch into, can we actually test this? Can we actually turn this into some, not just some interesting plots, but something that's an actual tool, actually usable, Right, until then, stay safe. I'll be posting a couple of videos on the main channel as well, so I'll post a recap. I'm going to post a video just summarizing the paper we had in Cell last week. I've actually prepared that, and I wanted to do that last week and just couldn't get around to it. I decided I'm going to do these short videos, like a 1-minute video on all the papers we've done so far, probably going back sort of reverse chronological order, trying to remember maybe some of the details of all the papers I've done in the last many years. And so I'll be so probably by the end of the week I'll post a couple of these on the main channel. So do follow and subscribe. Otherwise, I'll obviously post a recap video of this. This time there's not going to be a long lag, because there's nothing running in the background, just these results. So there's a mailing list. Please subscribe to the mailing list to keep abreast. There's a Discord server, or you can email me personally. Do check out the other work we do. We have papers. We just put out a release of ArgNorm, which is this arg normalization, for which there's a great video by Vedant as well. So check all of that out. Keep in touch, and I will see you next week.